Hello and welcome. My name is Manoj Muraikar, and in today's lecture I will give an overview of cohort and case control studies. In earlier lectures, my colleagues have given you an overview of different study designs. Let us have a quick recap. Epidemiological studies are broadly divided into two categories. First is experimental studies and second is observational studies. And this categorization is based on this question: did the investigator assign the exposure? So, in experimental studies, investigator assigns the exposure, and this exposure could be in terms of new intervention, new drug or new vaccine. These studies are further classified into randomized and non-randomized studies based on random allocation of exposure. On the other hand, in observational studies, investigator does not assign the exposure. If there is no comparison group in observational studies, such studies are called as descriptive studies, and in these studies we describe the health event in terms of time, place and person. If there is a comparison group in observational studies, these studies are called as analytical studies, which are further divided based on the direction of these studies. Cohort studies, they progress from exposures to outcome, whereas case control study progress from outcomes to exposure, and in cross sectional studies we measure exposures and outcome at the same time. So, in short, analytical studies are the one in which investigator does not assign the exposure, there is no randomization. But so what investigator does essentially is he carefully measures the pattern of exposure and disease in population. There is a comparison group in analytical studies, and using this comparison group, the investigator makes inferences about exposure and the disease. Let me first talk about cohort study. The word cohort has a military origin, military roots rather than medical roots. In Roman army, a 300 to 600 man unit was called as cohort, whereas in epidemiology, the word cohort is a group of individuals sharing some common characteristic. One such example could be a birth cohort. All the children who are born today will form today's birth cohort. Let us see how the design of cohort study is. As we know, cohort study will progress from exposure to outcome, and in this particular example, exposure is say cigarette smoking and outcome is development of cardiovascular disease. Cohort studies begin with selection of exposed and unexposed cohort, and in this example it would be people who are cigarette smoking and those who are not smoking. Once we identify this cohort, these cohorts are followed in time. Some of these exposed and unexposed individuals will develop the disease, that is cardiovascular disease, whereas the remaining people would remain non-diseased. We will then calculate the incidence of cardiovascular disease in exposed population and in unexposed population, and we will compare this incidence using a measure of association called as relative risk. I will talk about this relative risk little later. There are three types of cohort studies. The first is prospective cohort study. In the prospective cohort study, your study starts, by the time your study starts, exposure and disease has not yet occurred. Whereas in case of your retrospective cohort study, both exposures and disease has already occurred when you start the study. And there is a combination of these two approaches which is called as bidirectional study or ambispective study, wherein when your study starts, the exposure has already occurred and then you follow these exposed and unexposed individuals till they develop the outcome. Let me explain these different type of studies by giving some example. First example is of Framingham heart study, which is one of the oldest cohort study initiated in 1940s. The objective of this study was to identify risk factors for cardiovascular diseases. This study was conducted in a town of Framingham, which had a population of about 28,000. So, this population, in fact, a sample of this population was then divided into two based on those having a risk factor and those who was not having the risk factor. And the investigators considered several risk factors, one of which was hypertension. So, for the purpose of they classified this cohort into this population into those who had hypertension and those who did not have hypertension. This cohort was then followed up in time and the incidence of cardiovascular diseases was compared in two cohorts. This is an example of retrospective cohort study. The objective of this study was to evaluate the role of aniline dyes or exposure to aniline dyes and development of urinary bladder cancer. So, the investigators for this study recruited about 4,622 workers who were working in dye industry between 1920 and 1951. So, this recruitment was based on available records in those factories. Investigator also reviewed the death records of these 4,622 individuals and essentially they looked about any mention of urinary bladder tumors on their death records. And then they compared the death rates in this population with that of the expected number of deaths in of bladder cancer using national statistics. So, by the time the study started, both exposure which is, and outcome had occurred. So, these are the four important components of cohort study. First is selection of study population, second is gathering baseline information, third is following up this cohort, and fourth is doing the analysis. There could be two approaches of selecting study population. You could select your cohort from general population as was done in case of Framingham study, or you could select a subset of general population as was done in nurses health study. The second approach could be selecting spatial exposure groups such as occupational groups. Once you select this study population, the next important step is doing collecting baseline information from this population. And the objective of this step is to have a valid assessment of exposure status of members of cohort. And by doing this baseline information, we can also collect identification details of the study population. We can exclude those individuals who are having the disease of interest at baseline, so that the population which remains is at risk of developing the disease. And we can also obtain the data about other risk factors or other exposure variables. As we have seen, in analytical study there is a comparison group, and we have two options of having comparison group in case of cohort study. One is the internal comparison group, and the unexposed persons in the population is taken as a internal comparison group. An example could be a Framingham cohort study, wherein those who had hypertension were considered as exposed population and those who were normotensive was unexposed population. Sometimes it is not possible to have internal comparison group, as we have seen in case of aniline dye example. Everybody in those factories were exposed, and it was not possible to have an internal comparison group, and therefore the investigators compared the death rates with that of general population. So, you could take an external comparison group in such situations. Once you recruit your exposed and unexposed population, the next very important step is doing good follow up of these population. There could be three principles of having good follow up. First is having a uniform surveillance in exposed and unexposed group, having complete assessment of exposures and outcomes, and third is using a standardized diagnosis of outcomes, especially since the cohort studies can last for a long period of time. This is how the data that in cohort study would look like. This is how the 2 by 2 table in cohort study would look like. We started the study with selecting people who are exposed, which is A plus B, and people who are unexposed, which is C plus D, and we followed these people. So, A plus C developed the disease and B plus D remained undeceased. So, at the beginning of the study we know who were exposed and who were not exposed. So, we can calculate the incidence of disease in exposed population, which can be given by formula A upon A plus B, and incidence in unexposed population would be in C upon C plus D, and the ratio of these two incidences is a relative risk. How do you interpret this relative risk? There could be three possible scenarios of relative risk. One is relative risk is equal to 1. If a relative risk is 1, it means that incidence of disease in exposed and unexposed population is same, and we can interpret that the exposure is not associated with the disease. Relative risk could be more than 1, which means that incidence of disease is higher in exposed population as compared to unexposed population, and we can interpret that the exposure is positively associated with the disease. Relative risk can also be less than 1, which means that incidence of disease in exposed population is lower than unexposed population, and here we can interpret that exposure is negatively associated with the disease. Cohort studies have certain strengths as well as certain weaknesses. So, what are their strengths? They allow calculation of incidence, because when we start the study, we start the study with selecting exposed population and unexposed population, and we follow them in time. Therefore, it is possible for us to calculate the incidence of disease. We can examine multiple outcomes for a given exposures. We are very confident about temporality in case of cohort study. And last is that these studies are especially useful for rare exposures. So, what are the weaknesses? The sample size for cohort study could be very large. We need to follow these people for a very long time, and therefore, cohort studies could be expensive and time consuming. They are not recommended for diseases which are rare or diseases which have a very long latency. And if you do not have a good follow up or a differential loss in exposed and unexposed population, it could introduce certain amount of bias in your study. Let us now see the case control study. Case control studies are exactly opposite to that of cohort study when it comes to the direction or logic of the study. Let us first see the design of cohort study. And to explain the design, I will use the example of one of the very old case control study conducted by Doll and Hill. The objective of this study was to test the association between cigarette smoking and lung cancer. As the name suggests, case control, we start with selecting cases, and control is the one who does not have the disease in question. So, the first step is selecting cases. So, for this study, Doll and Hill selected lung cancer cases who were admitted in hospital in about 20 hospitals in London. These cases were all histopathologically proven cases of lung cancer. So, for each case they selected a control, which was a non-lung cancer patient admitted in the same hospital, and these cases and controls are then interviewed to find out their prior exposures. So, Doll and Hill found out how many of the cases were cigarette smokers. They had a detailed questionnaire to ask about history of cigarette smoking. They asked how many of them were smoking, what was the age of starting smoking, what type of cigarette they were smoking, and so on and so forth. So, we find out how many of the cases are exposed, how many of the controls are exposed, and same way how many of the cases are unexposed. And based on this data, we calculate what is called as exposure odds among cases and exposure odds among controls. And then we calculate what is known as odds ratio as a measure of association between exposure and outcome. Like cohort study, there are 4 important elements of case control study. First is selecting cases, second is selecting controls, and third is collecting valid information about exposures and then doing the analysis. Coming to the selection of cases, theoretically all people in the source population who develop the disease of interest could be included in your study, or you could sample these cases. However, one thing you should keep in mind that the selection of cases should be independent of exposure under study. We need to have clear definition of outcome to be studied. One also need to decide whether to include prevalent cases or should include only incident cases. Prevalent cases means those cases which are already occurred in the past, whereas incident cases are the newly occurring cases. So, if you take a prevalent cases, they are readily available, and by including them you can save time and money. But in spite of this obvious advantage, it is generally recommended to include incident cases, mainly because prevalent cases may be related more to the survival with the disease than the development of disease. Where from I can select these cases? Again, there could be two important sources. One is from hospitals or clinics. It is easier to find cases in these hospitals and clinics. However, it is quite possible that cases which are admitted are more severe cases and may not represent the cases in community. The other approach could be a population based selection of cases, and one such example could be cancer registry. And these cases are more likely to represent the source population, primarily because they are not biased by factors drawing patient to a particular hospital. Where from I can select the controls? As I mentioned earlier, control is the one who does not have the disease under investigation. Why do we need control? Controls essentially represent the distribution of exposure in source population. So, they tell you the background rate of exposure in the population from which cases have come. Like cases, they also need to be selected independent of the exposure status. There again could be three sources of controls. First is the population based sources, population based controls, and you could sample from general population. Second is you could select controls from health facility, and in case of Dole and Hill study, they selected control from the health facility, but we could select patient with other diseases. And the third source of controls could be case based controls, that is from friends or neighborhood. Once you select cases and control, the next important step is collecting data about past exposures. And again, there are three important principles: collecting the data on exposures objectively, so that your measurements are reproducible, accurately and precisely. Once you collect the data on exposures, this is how your 2 by 2 table will look like. This is exactly the same table which we saw for the cohort studies. However, in case control studies, when the study started, we knew who were cases and we knew who were controls. So, A plus C were cases to start with, and B plus D were the controls. And we found out that of the A plus C cases, A were exposed and C were unexposed, and same way B plus D controls, B were exposed and D were unexposed. In case control study, we cannot calculate incidence of disease like what we could calculate in case of cohort studies. So, what do? Then what we do is essentially we calculate a measure of association called odds ratio. This odds ratio is the odds that cases was exposed is given by this formula: probability that a case was exposed upon probability that a case was not exposed. And we know that probability a case was exposed is A upon A plus C, and probability that a case was not exposed is C upon A plus C, and the ratio of these two probabilities is A by C. Same way, we also calculate the odds that control was exposed, which comes out to be B by D, and the ratio of these two odds becomes the odds ratio, which is AB by BC, which is nothing but a cross product ratio. How to interpret this odds ratio? Again, like relative risk, there could be 3 scenarios. One is odds ratio equal to 1. If a odds ratio is equal to 1, it means that odds of exposure among cases and controls are the same, and we can conclude that exposure is not associated with disease in such situation. Odds ratio could be more than 1. It means that your odds of exposure among cases are higher than that of controls, and we can conclude that exposure is positively associated with the disease. If odds ratio is less than 1, it means that odds of exposure are among cases are lower than that of controls, and we can conclude that exposure is negatively associated with the disease. Case control study also has certain strengths and weaknesses. These studies are especially good if the outcome is rare or the disease has a long latency period. They are fairly easy or quick to conduct and hence inexpensive, requires relatively less subjects than that of cohort studies, and multiple exposures or risk factors can be examined at the same time. The weaknesses of cohort study include that they are susceptible to several biases. The recall bias is one of the most important bias. Sometimes selection of control could be a problem. Selection of an appropriate comparison group may be difficult, and we cannot calculate incidence of disease in these studies. Thank you.